Okay, welcome to example 29. In our integration topic, we are looking at integration by parts, and in example 28 we had our first look at repeated integration by parts, so this is another one kind of like it. So another chance just to get your head round having to do more than one cycle through the integration by parts process, and it happens when we can't particularly when there's polynomials in the expression, when it's an order of two or more on the variable. So we know we're going to have to do it twice. If there's an x cubed term, you'll be stuck there 3 times, but at the moment we've just kept it as x squared, so I'm trying to keep it as easy as I can. So we run through the process of integration by parts. Remember, we're looking at creating this kind of shape here. We need to nominate u and v dash. So let's do that. So if we say that u is going to be our polynomial term, which is x squared, and v dash is going to be sine 3x, sine 3x. So we go through the process of differentiating the first term and integrating the second term. So we need to integrate sine 3x with respect to x, and that's going to be cos 3x, so it's going to be sine integrates to negative cos, it should be negative cos 3x divided by the derivative of 3x, which is 3, so we end up with negative a third cos x, plus c, of course, which we're not going to use at that point. But it means that if I want to update my integral calculation, I'm going to use black, keep it black, equals. Okay, so using the integration by parts kind of rule, formula, call it what you want, we're going to have u times v, which is x squared times negative a third cos 3x minus the integral of what we've got, u dash v. When I set it out like this with u and u dash underneath, v dash and v, there's also a position, as well as a formula, there's also a positional pattern that I use, which is, it's the kind of the top left, bottom right, diagonal, and then the bottom two across the way. So it helps to kind of remind me which ones to use. So I've got u dash is 2x, and we've also then got negative a third cos 3x with respect to x. So it's a bit messy there. I'm going to tidy it up first of all before we have a look at anything else. So I've got negative, I'm just going to put x squared over 3 cos 3x. I'm going to try and take out any multipliers here. I've got a constant, I've got a 2, and I've got a negative a third. They're both multiplying. So if I take the negative a third out, it's going to become plus 2/3 as my multiplier. You happy with that? Times the integral of x cos 3x dx. So the two number multipliers are now outside of the integration. And that's us so far. We can't do anything with that integral at the moment because it's a product of terms in x. So we need to use integration by parts. It's good to kind of visually give an idea of what you're trying to do. I need to work that out. So what we'll do is we'll set that up again. U is x and v dash is cos 3x. So the derivative becomes 1, and the integral v is going to be the integral of cos 3x with respect to x, and cos integrates to positive sine, so we've got sine 3x again divided by the derivative of 3x, which is a third, and we've got plus c. We may use that just now, so it's good all to keep it in and then think, do I need it? So what have we got? We're actually trying to work out the integral of x cos 3x with respect to x. So that's the bit that we've taken out of the bigger integral, and what we're saying here is that that's the same as, there's my pattern, top left, bottom right, so it's u v, so it's x times, I'll just write the third in there, third x times the sine of 3x minus the integral of u dash v. So it's 1 times a third sine 3x. I'm going to put the third here and just write sine 3x with respect to x. And look, I can do that because I've only got one term in x there. So I've got 1/3 x sine 3x minus a third times the integral of sine 3x. Don't rush it, okay? Sine 3x integrates to negative cos, because we did that. It's actually the same. We've got the answer up there, haven't we? Negative a third cos 3x plus c. And if I multiply that out, I get 1/3 x sine 3x plus 1/9 cos 3x plus c. Again, it doesn't matter. You don't have to multiply this plus c by negative a third. Technically, it should be in there at that point in time, but it's the plus c is slightly of a movable feast. So we've got that. That's really what we're trying to do. So this whole thing, we're going to substitute in for the integral of x cos 3x dx. Okay, so let's try and do that. So I'm actually going to bring that all the way over here because I need a little bit of extra room. So I'm going to put back at the top the integral of x squared sine 3x with respect to x gives us that, and then that. So we can continue our solution. Oops, okay, plus 2/3 times. Now here we go. We're going to substitute it in 1/3 x sine 3x plus 1/9 cos 3x plus c. Okay, my computer's about to run out of battery, that's why it's been a bit slow. And if I multiply all that out, I'll get negative x squared over 3 cos 3x. That remains the same. Multiplying out these brackets by 2/3, we get 2/9 times x sine 3x, and then 2/3 times 1/9 is 2/27 times cos 3x. Again, we could say times 2/3 c, but we don't need to. That's just going to be c will work out at some other point. We could take a common factor of cos 3x, but do you know what? I'm not going to bother. That's us done repeated integration by parts, and we've got an answer that's going to work as far as I'm concerned. Okay, so I hope that's helpful. Just doing these examples, getting the idea of not doing just one but two, and also making sure that you keep it kind of your working clear and concise, both for your benefit and anybody who's trying to read it. Okay, so I hope that's helpful, and you keep working with your integration.